Tesla just filed new permits, and buried inside those documents are 4 engineering changes that were never supposed to be public. Not minor tweaks, not cosmetic updates, fundamental structural changes to the Cybercab. Now here is why this matters. The original Cybercab concept was radical: no steering wheel, no pedals, fully autonomous, minimalist interior, ultra-fast production design. It was supposed to be the purest form of robotaxi transportation, but new filings suggest something changed, something regulators forced, something engineers quietly improved, or something Elon Musk decided to completely rethink. Tesla is moving aggressively toward large-scale robotaxi deployment, and permits do not get updated unless hardware changes. So the question is simple: what exactly did Tesla modify? And why were these changes not announced publicly? In this video, we are going to break down the new permit filings, the 4 forbidden engineering updates, what they mean for production, and whether this delays or accelerates Cybercab rollout. Quick reminder before we go deeper: if you want realistic Tesla breakdowns that go beyond headlines and dig into what the engineering actually means, subscribe to the channel and turn on notifications. We focus on facts, not hype. Now let us start with the first change, and this one completely alters the safety narrative. Change 1: structural reinforcement. Why this is a big deal? The first permit update suggests a structural revision to the Cybercab platform, and this is not cosmetic, this is foundational. Originally, the Cybercab was designed around extreme manufacturing simplicity: minimal parts, large Giga cast sections, ultra-lightweight architecture, optimized for speed of production. But new filings indicate reinforcement modifications to the underbody and side impact zones. Why would Tesla do this? Because autonomous vehicles face a different regulatory standard. When a vehicle has no steering wheel and no pedals, regulators demand higher structural redundancy. There is no human fallback, so crash survivability becomes even more critical. Tesla likely adjusted side pillar thickness, battery enclosure shielding, front crash absorption, geometry, rear structural bracing. These changes may slightly increase weight, but they dramatically improve regulatory approval chances. Now here is why this is interesting. The Cybercab was originally engineered to maximize Giga casting efficiency. Large single-piece castings reduce complexity and cost. However, reinforcing structure often means adding material or redesigning casting molds. That means updated tooling, and updated tooling means investment. So Tesla would not make this change casually. This suggests one of 2 things: either regulators required stronger crash compliance data, or Tesla discovered improvements during internal testing. Now let us be clear, this does not mean the original Cybercab was unsafe. It means production intent vehicles often differ from concept unveilings. Engineering reality always refines stage presentations. Here is the key takeaway: if Tesla reinforced the structure, it signals seriousness. It means Cybercab is moving from concept vision to real-world certification. That transition is where most ambitious projects slow down, but it is also where projects become real, and the structural update may be the clearest sign yet that Tesla is preparing Cybercab for official road approval. Now the second change is even more controversial, because it challenges the entire no steering wheel philosophy. Change 2: is Tesla adding a backup control system? Now this is where things get controversial. The Cybercab was introduced as a fully autonomous vehicle. No steering wheel. No pedals. No driver controls. Pure autonomy. That was the entire point, but updated permit language suggests something interesting there. Are references to secondary control architecture and override capability integration. Now that does not automatically mean a steering wheel is coming back, but it does suggest redundancy. And in the world of autonomous vehicles, redundancy is everything. Tesla has always pushed the idea that full self-driving can operate without human intervention. However, regulators think differently. Most transportation authorities require emergency override pathways, diagnostic access, manual fallback in certain scenarios, remote operator intervention capability. So what might Tesla be doing? There are 3 realistic possibilities. Possibility 1. Hidden foldable controls. Tesla could integrate a deployable steering module, used only for regulatory testing or limited jurisdictions, not visible in normal use, not part of the customer-facing design, but present for compliance. Possibility 2. Remote human control system instead of physical controls. Tesla may be enhancing teleoperation. Capability. Meaning a remote operator can take over in rare edge cases. This would align with Robotaxi models in other markets. Possibility 3. Software-locked emergency mode. The vehicle may include a restricted control interface, accessible only to certified technicians or regulators. Not public. Not marketed, but technically present. Now here is why this matters. If Tesla reintroduces any form of manual override, even temporarily, it slightly weakens the bold "no driver needed" narrative, but at the same time, it dramatically increases approval odds because regulators care less about philosophy and more about fail-safes. The key insight here is this: adding redundancy does not mean Tesla lacks confidence. It means Tesla is adapting to real-world approval pathways. And if Cybercab is truly intended for mass deployment, regulatory flexibility is essential. But the third change is even more fascinating because it affects production speed directly, and that goes straight to Tesla's long-term cost advantage. If you appreciate deep engineering breakdowns instead of surface-level headlines, subscribe to the channel and turn on notifications. We analyze what these changes actually mean. Change 3. Giga casting revision. This changes cost structure. Now we move from safety to production. And this might be the most important change of all. Permit documentation suggests adjustments to the casting architecture and rear structural assembly. That may sound technical. But this directly affects how fast and how cheaply Cybercab can be produced. Originally, the Cybercab was expected to push Tesla's unboxed manufacturing concept to the extreme: fewer structural parts, larger single piece. Giga cast sections, simplified assembly flow, ultra-fast production cycles. The goal? Produce vehicles in minutes instead of hours. Tesla has already pioneered large underbody castings in previous models, but Cybercab was expected to go further. Now, the permit updates indicate possible mold redesign and structural segmentation adjustments. What does that mean? It likely means Tesla discovered limitations in cooling time efficiency. Material stress distribution, repairability, concerns. Or crash compliance under real-world testing. Large single-piece castings are efficient, but they are unforgiving if
look at the diagnostics
one section fails quality control. The entire casting is scrapped. By slightly segmenting or reinforcing certain sections, Tesla may improve yield rates, structural reliability, and long-term durability. Now here is the trade-off: more segmentation can slightly reduce manufacturing speed, but it can dramatically reduce defect losses. And in mass robotaxi production, yield stability matters more than theoretical peak speed. This tells us something important. Tesla is optimizing for scalable reliability, not just flashy production numbers. And that is a mature move, because concept presentations highlight maximum capability. Production engineering prioritizes repeatable consistency. If Tesla adjusted the casting architecture, it suggests Cybercab is moving closer to production intent tooling. Tooling changes are expensive. Companies do not revise Giga press molds unless they are serious about long-term deployment, and that brings us to the fourth change. This one affects the entire autonomous architecture itself, and it could redefine how Cybercab interacts with city infrastructure. Change 4. Did Tesla quietly upgrade the autonomy hardware? Now we come to the fourth and possibly most sensitive change: the autonomy system itself. Permit updates reference modifications to the vehicle perception architecture and onboard compute configuration. That is regulatory language, but in simple terms, it means Tesla likely upgraded either the sensor suite. The onboard AI computer, or both. Now, this matters enormously. Because Cybercab was introduced as a pure camera-based autonomous vehicle. No visible LiDAR tower. No bulky roof sensors. No radar arrays. Just vision-based full self-driving. Tesla has publicly committed to camera-first autonomy, but regulators in cities demand something more than philosophy. They demand proven redundancy. So what could this update mean? Possibility 1, higher resolution camera array. Tesla may have upgraded to newer generation cameras with improved low-light performance and dynamic range. Urban, robotaxis face difficult conditions, heavy rain, construction zones. Glare died night. Traffic. Better vision sensors improve safety confidence during permit approval. Possibility 2, AI compute hardware upgrade. Tesla's full self-driving depends heavily on onboard processing. If Cybercab is intended to operate continuously as a robotaxi, it needs higher thermal stability, more consistent real-time processing. Better edge case handling. Upgrading to a next-generation self-driving computer would allow faster neural network inference, more complex prediction modeling. Better real-time obstacle classification. That is not marketing, that is survival in real city traffic. Possibility 3, hidden redundant sensors. This is the controversial one. Tesla could be integrating additional short-range sensing hardware inside the body structure, not visible externally, not advertised, but included for regulatory. Redundancy. Some cities may require additional verification systems, even if Tesla does not promote them publicly. Now here is why this is called a forbidden change, because it slightly challenges the original simplicity narrative the Cybercab reveal emphasized. Minimalism, but real-world deployment often requires compromise. And compromise does not mean failure. It means maturity. If Tesla upgraded sensors or compute hardware before large-scale rollout, that signals readiness. It means Cybercab is transitioning from presentation mode to operational mode. Autonomous vehicles are judged by safety statistics, not keynote speeches, and hardware revisions are assigned. Tesla is preparing for that scrutiny. Now, we have covered the 4 changes: structural reinforcement, backup control pathway, manufacturing revision, autonomy, hardware upgrade. The final question is simple. Do these changes delay Cybercab or accelerate it? That is where we go next, delay or acceleration. So after analyzing the 4 forbidden engineering changes, let us answer the real question. Do these updates signal problems or progress? Here is the honest assessment. They signal progress and serious intent. Think about it logically. Companies do not revise crash structures, update autonomy hardware, and modify manufacturing tooling unless they are preparing for regulatory approval and real-world scaling. Concept. Vehicles stay frozen. Production vehicles evolve. Tesla is clearly shifting Cybercab from visionary concept to deployable product. Let us quickly recap what these changes really mean. Structural reinforcement means compliance readiness. Backup control architecture means regulatory flexibility. Manufacturing revisions mean yield optimization. Autonomy hardware upgrades mean real world safety preparation. None of those are cosmetic. All of those are production stage behaviors. Now here is the deeper insight. If Tesla had kept Cybercab exactly as originally presented, regulators would likely slow approval. Cities would hesitate. Insurance companies would demand more guarantees. By quietly strengthening the platform, Tesla increases approval probability. That does not weaken the vision. It strengthens the timeline. Will this delay initial rollout slightly? Possibly. Tooling revisions and hardware upgrades take time, but long-term deployment speed matters. More than a flashy launch date, robotaxi networks require trust, and trust requires engineering redundancy. So, instead of asking, why did Tesla change the Cybercab? The better question is, how serious is Tesla about deploying millions of them? Because these changes look like the behavior of a company preparing for mass-scale autonomy. Not a company chasing headlines. Now, here is the final takeaway. Cybercab is no longer just an idea. It is entering the compliance and scaling phase, and that is where real disruption begins. If you want in-depth Tesla breakdowns that focus on engineering reality instead of hype, subscribe to the channel and turn on notifications. Comment below. Do you think Tesla should stick to the pure no steering wheel vision, or is adding redundancy the smarter move? In the next video, we are breaking down whether Cybercab could actually be produced in under 10 seconds per vehicle using Giga casting and unboxed manufacturing. That changes the economics entirely, so stay tuned. Thank you for watching. Stay curious, stay analytical, and I will see you in the next one.